All right, here we go, pre-algebra video. Just to hit on a couple of things. First, you do have to know how to combine like terms. You're only allowed to put things together that have the exact same variable with the exact amount of exponents, okay? Exponent is up here, not these. I don't want you to wonder, can I add a 3x and a 5x? Yes, you can, okay? But you can't add a 5x with a minus 2. That's not allowed, okay? You cannot add or subtract anything unless it has the exact same variable. Now, let's get to that point. So here you have to find everything. So let's start with the first one. So I'm looking for everything that has an x. So I have 3x, 5x, and a plus 9x. You have to mark what's next to it so then you know what it's doing. So I'll bring that down. 3x plus 5x plus 9x. And that will tell me how many x's I have. I have 3 of them, 5 of them. That means I have 8, and then 9. So I have 17 x's. Now I'm looking at just constants. Constants are numbers with no variables. They have the same amount of variables because all of them have no variables. So I have -2 plus 8 and then -2. Now when you're putting a positive and negative integers together, the rule is you put the number furthest from the 0 on top. So I'm going to go 8, that's a positive, and -2 on the bottom. Then in some instances, it'll look like a regular problem. So 8 minus 2, that is 6. Okay, so it's a positive 6. So now I have positive 6 and a -2. So I'm going to put that underneath it. Again, this has ended in a result. This is a positive 6. In a positive result, so then it's just going to be 6 minus 2. That's going to be a positive 4, right? So my end result is a positive 17 and a positive 4. If you're going to stream them in a line, you write them like this. You could have also written like this, 4 plus 17x, all right? That doesn't matter, as long as you go with the sign in the front. But if the sign in the front, if it's positive, it just vanishes. Okay, so that's the first thing you have to know how to do. The next thing you have to know how to do is combine like terms and then solve a one-step equation. So if you combine these, a 3x and a 5x, you're going to get 8x. And that equals 24. Now, for this, I have to solve 8 times something equals 24. So you probably already know the answer. But that means you can only answer the questions that you know the multiples of. So if I start making this fraction or 0.737, it starts to become more difficult. So you have to know the process of how to solve these. So I can increase the level of difficulty, and still, if you know the process and how to do math, it will all be solvable. So you do have to learn the steps. To solve these correctly, you always have to do the opposite of whatever is happening to the x to both sides of the equation. So now we're looking at this, right? And now 8 is multiplying with x. So the opposite of multiplying with x is dividing. So I'm going to divide this. This is me dividing. This is how I divide. You won't see me do this symbol all year long. It will be like this, okay? So 8 divided by 8 is going to give you 1. And how do you write 1x? You just write x. But whatever you do to one side of the equal sign, you must do to the other side. So we're going to divide this by 8, and now my answer is 3, which is probably what you were thinking, but now you know how to solve any problem. Because if I would have made this 0.1, okay, it wouldn't be 3. And you wouldn't be able to solve it immediately in your head in 2 seconds. You'd need to know the process. So that's why the process is important. Knowing the process means there's no work that somebody can give you that is unsolvable. But look, we had to combine like terms. We're only allowed to have one x and one constant on a side of an equation at a time. Okay? You're not allowed to have multiples of things. You have to shrink it until the end result is one of each. So here we go again. Here we only have one x. So that's fine. We can come down here. But I have 2 constants. I don't want 2 constants. I want 1. So 3 minus 8. 8 is the number furthest from the 0, so it goes on the top of my little addition-subtraction situation over here. I put the positive 3 on the bottom, okay? The answer, when you're adding and subtracting, always copies the sign of the top number. So I know the answer is going to be negative. If these signs are different, then I'm just going to be subtracting these. So the end result is 5. So minus 5 or negative 5, same thing. and the 12 goes down. It would be a negative 5 if I was multiplying something to it, but right now you can see that we're not multiplying, we're adding, subtracting, so it's going to be a minus sign for now. Now you think, again, what is the opposite of what is happening to the x? X minus 5, I'm going to add 5. So if I subtract 5 and then add 5, then nothing's happened. So this is 0. X plus 0 is just x. But again, whatever you do to one side, you have to do to the other. So this is going to be 17. All right, here we go. What is the opposite of what is happening to x in this problem? Okay, it's being multiplied by 2 over 3. The opposite of being multiplied by 2 over 3 is multiplying by 3 over 2. Whatever you do to one side, you do to the other. 3 over 2. And my answer is going to be x equals 3, because multiplying fractions is just multiplying the top, then multiplying the bottom. So it's going to be 3 over 10. This is only for multiplication. You do not do straight across for adding or subtracting fractions. Multiplying is the easiest one. So that's it. Mr. Caspers, you didn't explain what happened here. This number's going to get bigger, this number's going to get bigger. It doesn't make any sense. Well, when you multiply a fraction by its inverse, okay, 2 times 3, that'll give us 6. And 3 times 2, that will also give us 6. 6 divided by 6 equals 1. And how do you write 1x? X. All right. Now we're going to two-step equations. Two-step equations, right here, has two things happening to the x. So you have to think to yourself, okay, I have to think, what is happening to the x? And I'm going to write it over here on the left. Okay, if x was an actual number, ignore this on the left, on the right for right now. If x was a real number, what would you do first? If I told you x was 2, okay, remember there's 6 times this, and there's plus 5. What would you do first in solving this problem? If you're following the order of operations, okay, parentheses first, exponent, then multiplying, division, then adding, subtracting. So we'd be doing the multiplying first. So the first thing you would do is multiply with 6, right? Then you would have added 5. So that's the steps, first and second, right? Now we're going to do everything opposite. So not only are we going to do the opposite of plus 5 and the opposite of multiplying 6, we're going to do it in the opposite order to remove them. So first thing we're going to do is the opposite of plus 5, which is minus 5, okay? And this will get rid of this portion. And whatever you do to one side of the equal sign, you must do to the other. The 6x comes down, and here we're left with 30. 6x is all by itself. Now, the opposite of the first thing, which is multiplying by 6, is dividing by 6. That's gone. Dividing by 6. X equals 5. Same thing here, okay? The first thing that's going to happen to the x is it's going to be multiplied by 3.2. Then the next thing is it's going to subtract 10. Okay, so that's the first thing that's going to happen to the x, and that's the second thing that's going to happen to the x. So we're going to do it in reverse order. So we're going to do, what's the opposite of subtracting 10? Adding 10. Adding 10, you're left with 3.2x equals 16. Then, what's the opposite of multiplying by 3.2? Dividing by 3.2. So we're going to divide by 3.2. Okay? So it's going to be 16 divided by 3.2. Move the decimal point, move the decimal point. You have 160. That goes 0, 0, 5. That's going to give us 160. So the answer is 5 for this problem. So x equals 5. Last one we're going to work out. So then I feel like we covered all our bases, is this problem here. We're going to figure out what's going to happen to the x, and then we're going to do the opposite of whatever's happening to the x. So the first thing that's going to happen to the x is being divided by 9. So what we're going to do is write it here. So we're going to write that weird symbol that you guys like, divide by 9, and then we're going to write add 2. Remember, we're going to start at the bottom. So we're getting rid of the plus 2 by doing minus 2. Minus 2, okay? We're left with x over 9 equals 5. What's the opposite of dividing by 9? Multiplying by 9. If I multiply by 9 and divide by 9, it's going to make 1x. So, x. But whatever you do to one side, you have to do to the other. So that'll end up at 45. All right, that's it.